Hey everybody, welcome back to our ASUS Z87 Haswell live stream. JJ's still here, I'm still here. We have removed the glut of motherboards that were sitting in front of us, and now we're actually going to get into using them. First up, we're going to talk about a new set of software you guys have built, AISuite III as it's called. We're going to go over kind of what some of the form and function changes are, and actually how you use it for the four-way optimization, as you call it.
Yeah, definitely. So let's go ahead and switch over here.
Yep. A lot of great feedback so far on the motherboard side. So now let's see what we can do on software and overclocking. We're going to do some overclocking on this rig. We're going to do some overclocking on a secondary rig. And of course, don't forget, we have some stuff to give away.
Okay.
Obviously, it gets people's attention.
So here we've got the brand new application interface. So we can see this actually is quite a bit different than if you guys are familiar with the previous AI suite. It looks very, very, very different. So the goal here was to try to give something a little bit that had more of kind of like an edgy or like kind of HUD-based feel to it, but also have a kind of persistent level of information that was supplied. So just doing a quick kind of roundabout is out on the bottom, of course, we're now persistently displaying CPU frequency, as well as actually there will also be DRAM clock frequency that will be available in the finalized version. This version I'm running here is actually the pre-release version, but the final version, which will be included with your boards, or you can get at support.asus.com, will have that included within it. You can click on it, you can see CPU utilization, you can see all your core voltages, your temperatures, your fan speeds. You can go in here and you can tweak and tune how you want to set all your monitoring and tuning, and that's going to persistently be visible wherever you're at. And in this home screen right here, the four-way optimization technology is pretty much us bridging together previous technologies that we've had integrated in our software suite, but all in one simplified solution. So our auto-tuning technology, which was dynamic real-time overclocking specific to your system, your cooling, your memory, your CPU, and whatnot. Our fan expert technology, which dynamically calibrated real-time your fans that you had connected to your system. Yep. Our EPU, which was a way to power manage your system in terms of power consumption and voltage, and then our DigiPlus power controls, which tied into overclocking and efficiency adjustments. So this will report to you essentially kind of all your tuned parameters of operation, whether it's your overclock configuration, the benchmark information for each one of the CPU and the chassis fan headers, whether or not you've made adjustments to the power settings. So it's kind of like a affirmation to whatever your system's been tuned towards. And you also then have these optimized profiles depending on what you're going to be utilizing. So in high performance, it's maximizing, of course, clock frequency and overall system performance. And auto, it kind of makes an adjustment. And then you have other options as far as like a wave mode or power saving. Now, some cool things that we've done in terms of making some changes here. If let's say we go to TPU, TPU handles all kind of the frequency-related adjustments. So we still have all the same stuff you'd expect, like the multiplier, BCLK. You can do group tuning, or you can do per core tuning in terms of overclocking that all dynamically. We also offer, of course, full adjustment voltage options for like adaptive or manual. But a cool part too now is that we've gone ahead and incorporated full key and entry. So instead of just having to use slider tabs, you know, if I wanted to go ahead and define a voltage, I can now actually directly key that in. Where in previous generations, you just had to have you had to go through a slider mechanism.
It's a much nicer feature to have.
So you know, this just gives you more flexibility. The other thing too that we've introduced is a gradient system in terms of color coding. This is a really nice step because a lot of you guys might not be like me. I've worked with this platform for the last 8 months. I know the voltages and everything that I need to know inside and out, but you might be new to this and you might not necessarily what is safe, what's moderate, what's extreme. And these actual voltages are color coded. So you can see if I go just a little bit below, it's in white. And then if we go a little bit higher, it goes into yellow. And then if you see, we keep going, oh, now we're like in these extreme level of voltages. So it's just a visual way to immediately let you know, hey, you know what, you're in these corresponding areas, so you can be conscientious of that. It's a small touch, but it actually takes a lot of work because you have to link that into the UEFI. It's not a just pure software sequence. Because while this is software, keep in mind we're working all this on a hardware layer. So this is interfacing directly with the UEFI. So of course you can make adjustments to the CPU strap and the BCLK, which are of course options that we have for this generation in terms of fine-tuning the overclock. For the EPU, we have a lot of granularity here. You can go in and you can make real-time adjustments to different things like a voltage reduction. So if you want to go ahead and undervolt the CPU, you can go ahead and tune that, and it'll let you know, hey, you know, do you want to attempt to tune that? But this could potentially, of course, produce instability because you're providing less voltage to the CPU at the same frequency. You can even do quick things that normally take you a couple more steps, like changing power profile timings, your fan speed options for those different environments. You can even go into really cool options like here where we have configured max CPU power consumption. So you can actually customize the power target. So you know by default for this generation, I think it's 84 watts, right? Versus the previous generation, which was 77 watts.
Yep.
Well, you can go in and you can tune that to whatever you want. So you could tune this to 50 watts, 40 watts, 30 watts, and we'll automatically adjust the system's operating performance markers to match that CPU power consumption target. So this is a great way that if you want to maximize kind of like an efficiency to performance, you know, marker, maybe you're not necessarily always bent on having the absolute highest performance, but you still want great performance, you want to take advantage of the platform, you have some really cool levels of granularity and tweaking to how you can work with this. And this can even be tuned within our 4-way optimization. The digital power management options are, of course, very, very extensive. You know, you have full real-time control over things like OCP or current capability, the phase management in terms of how the phases respond depending on their load, whether it's extreme like they're always running or not running, even temperature-based adjustments. And lastly, we have our Fan Expert 2, which is still pretty much the, kind of the most extensive level of automatic fan tuning options you have available. It can independently go in there, check every single header, goes from minimum to maximums, logs all that information, allows us to remap, you know, the headers, rename them. We can go in and we can make adjustments. So like if we go to the chassis fan header, we could click into this and, you know, we could tell it where it's positioned, right? We could go ahead and relabel it, right? If we wanted to call chassis fan 1 back exhaust, we could label that to back exhaust. We could also go ahead and click on the fan curve itself and we could adjust how it responds to temperature, or we could lock it to a specific mode of operation as opposed to being a fixed mode. We could do dynamic mode. You can even do a really cool adjustment for the fan spin up time and spin down time. So you can adjust the granularity at how the fan ramps up between your delta points. That's important because if the fan's set to ramp very, very fast, right between let's say 1,000 to 3,000 RPM, it's going to be very abrupt. You'll hear like a whirling sound, right? Where if you tell it to be a really slow curve, right, the slow curve is really smooth, so you'll hear a much smoother ramp. So we're really allowing you a fine level of granularity of being able to control the acoustics. So that's a whole bunch of manual level control. Awesome. This is all real time in the OS. Yeah. Pretty much the same level of stuff that you have inside the UEFI. So you know, even for dyed-in tool enthusiasts like me, you know, you can feel comfortable to say, I'm not really compromising on anything by doing this inside of the operating system. If anything, you save more time because I'm not having to reboot and check. I can see this all dynamically occur. The big thing for this generation, though, is we've incorporated a feature called 4 optimization works with our dual intelligent processors. So this is now the 4th generation of this. And the goal here was ultimately to try to give you guys optimized efficiency and performance in a really simplified level. The reality is a lot of people, when they go from generation to generation, don't understand all the complexities of how to tweak and tune and manage their system. But at the end of the day, you buy these nice parts, you buy nicer memory, you buy a nicer cooler, you get all this, and you still want to be able to maximize it, right? Yeah. And we want to be able to do this for you in an easy and effective way. Okay. So that's what we're going to show with this 4-way optimization process. So before I jump into this, I just want to give a little bit of perspective, and maybe we can go into the system here. We can talk about actually what we have here to kind of show you how we're going to take the system. So right now we've got everything at bone stock settings. This is 3.5 gigahertz is the maximum turbo under all cores, right? So we've got our Pro board, so this is not the highest even end board that we offer, it's just our Z87 Pro, so this is the mid-range series board. We've got this awesome high-performance Noctua tower-based heatsink design with only a single fan, so it's a high-performance tower-based heatsink, gives us really good temperatures. We've got Kingston's HyperX Beast memory. This is 4 DIMMs, 16 gigabytes, 2133. We've got the 4770K on here. We've got, of course, this really nice Bit Phoenix Ghost chassis with 5 fans. So they're all connected to the motherboard, right? So we have these fans serving as an intake. Yep. So the 2 front fans. We then have 2 top fans here on the top of the chassis serving as an also intake, and then we have that back fan serving as an exhaust, right? So this is kind of very realistic of what I feel a normal enthusiast would be building for a Z87 based platform, right? A single GPU, GTX 670, and we've got a nice Seasonic X Series Platinum PSU, right? So this mirrors, you know, not something crazy, but something enthusiast oriented. So let's see what we can get out of it if we just go from stock to 4-way optimized. Okay. So when we click into this, we could just click on the start button, right? But if you wanted to have some more granularity, there are some second options. One is that you could click on advanced, and for this generation, we have given you more customization over our auto tuning process. Instead of just tuning the multiplier, if you want to tune the multiplier solely, you can just tune that. If you want to tune through the BCLK, you could tune the BCLK. Fast tuning will be a very short process, probably between about 3 to 4 minutes, and it will generally target probably about 4.3 gigahertz approximately. Extreme tuning will be fully system specific, so it will vary depending on whatever your cooling and your memory and your CPU margin allows for. You can also go ahead and have it do the EPU optimization, where it can essentially go ahead and preset power management modes for different controllers and different target power consumption markers, as well as fan optimization profiling. So we're going to go ahead and do the fan optimization profiling, the EPU, and the optimization for the away mode, and we're going to do pure ratio-based overclocking adjustment. So we're just going to go ahead now at this point, click Start, and it's going to go ahead and start the four-way optimization process. Now, as it goes through this, we're going to talk about a couple of things that are unique to this platform.
As we all live, guys.
As we noted here, right, with the Haswell platform and the integration of the Fiverr, is that we have, of course, this consistent power management that's being provided to the CPU. And ideally, this should help to provide continuity and consistency to the overclocking experience. But for this platform, through a lot of analysis, we have seen that there is a bit of variance between the CPU frequency that can be reached on the CPU and the corresponding voltages that are taken to drive these CPU frequencies. Now, this has always been true. There's never been the case that you don't have margin between CPUs, but there might be a little bit more margin for this generation. So an example is you could have CPUs that are outstanding in their CPU quality of maybe being like 4.6 gigahertz, could be done like at 1.15 voltage, and you could have CPUs that take also 4.6 but require as much as 1.4 volts.
Wow. Okay.
That's a very, very large swing in terms of the voltage range. Where this comes into place as a user is, one, it can be difficult for you to know what's the voltage that I need to get to my result in the first place, right? And two, there's also the consideration of that voltage, how does it affect me from a thermal standpoint? As you increase the voltage, you're going to exponentially increase the thermal output of the CPU. And that's what our four-way optimization process is really trying to help to manage for you, is that you don't know these characteristics because they're unique to your CPU. They will vary.
Sure.
You could build this same exact system and you could get a different set of results, right? And so that's what we've tried to do is give you an automated mechanism to give you a customized result specific to you. Now, before I continue on to what I was noting on, here we can see that the system has already started with a baseline overclock of 4.3 gigahertz. At this point, you could stop it. This is already a pretty big increase from the 3.5 gigahertz that you started off with from stock-based operation, right? But we're going to go ahead and continue to let it dynamically overclock.
Okay.
Now, two of the key things that are very special about the way that we're doing our overclock is that, one, we're going ahead and applying a stress test, which you can already see occurring, which it's fully loading up the CPU cores to go ahead and test initially for some form of stability as we're tuning our system, right? And this will dynamically increase the CPU clock frequency. Now, one thing that's different probably as opposed to most manual overclockers out there is that we do not use a manual or static voltage. Manual or static voltages are very inefficient. What they essentially mean is
where the same voltage is applied no matter what the load of the processor is.
Correct. Okay. And this is historically the way a lot of people overclock. The disadvantage is that with this architecture, and actually since about Sandy Bridge, you've been able to overclock with keeping C states, power savings, EST, all those things turned on.
Right.
So you're doing a very ineffective overclock because when the CPU frequency comes down, your voltage is still being locked at whatever you've defined. So if you put in like 1.2 volts, it's always at 1.2 volts. This adds more power consumption, increases idle temperature, and you actually add an element of what's called voltage degradation, which you can actually add conditioning to the chip, which can affect its lifespan. This is not a good thing. So the other options are new forms of voltages that are called offsets of some type, or interpolation or adaptive voltages. We only use an adaptive voltage policy, which means it's the most efficient in terms that when the CPU is in an idle state, it follows 100% the Intel voltage policy rule. So when the CPU frequency comes down, voltage comes down.
Gotcha.
Only under an overclock does the voltage get increased. So this is the best compromise of giving you best power efficiency, best idle thermal performance, but also giving us the voltage when we need to get to our higher CPU frequencies. We will also limit the maximum voltage supply to a maximum of 1.275 volts. We will not increase this. The main reason being is that in our analysis, after about 1.275 volts, almost no standard thermal solution on the market under the heaviest loads will be able to comfortably dissipate that level of voltage.
Gotcha.
So we want to keep things safe for you.
Somebody in the chat room asked if this was just the same as offset, and it's not.
It's not, because an offset would increase the voltage even at idle base levels. So if, let's say, our idle voltage was approximately 1 volt, an offset, if you applied it, would maybe still take it to like 1.1. right?
Right.
You know, it depends on what your offset is, but an adaptive voltage would actually keep the idle voltage at exactly what the Intel reference voltage
Adaptive
was.
essentially only increases the voltage when it gets past its default turbo state.
That's correct. So it's that optimal condition.
Okay.
So like I said, going back, we only go up to 1.275. Now this will slightly limit what the maximum overclockability could be on worse CPU samples, but at the same time, it probably also means that that CPU shouldn't maybe be overclocked to that margin because the thermal output that would need to be required could be quite high. So you can see here it's continuing to scale, and we also incorporated for this generation adaptive tuning per core. This is an advantage of the architecture, so we can tune 1 and 2 cores higher than we can tune 3 and 4 cores.
Okay.
And this is optimal because this platform also has more sensitivity to being able to hold higher CPU ratios or higher overclocks. So in this situation, maybe we give you like 47 on 1 and 2 threads, and we give you like 46 on 3 and 4 threads.
Gotcha.
So we can see here it's now continuing to scale, and it's dynamically moving through, making these adjustments. We've gotten all the way down to 4.7 gigahertz, which is pretty impressive, but the great thing is we've got this really awesome high-performance Noctua cooler. We've got this nice cooling configuration, so it's able to monitor this. As it's loading it, we do check the actual thermal throttle point of what the CPU temperature is being measured at.
Okay.
So we're dynamically taking into consideration the voltages, the frequencies, and even the temperature information, and this is all being logged in. As we're applying this, it's working in conjunction on a hardware layer with the UEFI to make these adjustments. And the great thing is about this, sure, even if you're a manual tuner, maybe you could say I could do all this.
Yes.
But the big thing comes down to is how much time would it take you? If you didn't know anything about the platform, even somebody that doesn't know anything about it, you're going to have to spend probably a couple of hours, maybe read your review, go through it a couple of times, be playing around a lot, and maybe it takes you 2, 4, 6. I know sometimes people, it takes them a couple of weeks, depending on how much free time they really have to sit down and tweak and tune their system. You know, our goal is at the end of maybe 10 to maybe 12 minutes, we're probably taking you to almost 70 to 80, maybe even 90% of what's realistically capable in a consistent and effective mechanism that, you know, in 9 out of 10 cases is going to be fully usable once it's completed. And
every iteration of this software has always impressed me, just how it improves things, right? And in automation, you're right, like the maybe we'll say the older, more mature overclockers will maybe look at this type of, they've always looked at this type of software with some kind of, you know,
disdain. It's okay. I mean, and we're conscientious of that. That's the reason why we're still going to show you how to manually clock your system, and we don't take away those options. Our job isn't to tell you as a user, you need to use this, right? But what I do feel very passionate about is I've been doing this for a long time. You've been doing this for a long time. I think it's hard to argue with the results that we're providing and saying, is it okay? Now, this is entirely okay for you guys. This is all real time. The system reached a maximum point. If you notice, we are at 4.9 on 2 cores and 4.8. And it was continuing to do the stress test. So eventually, at some point, either from thermal, from margin on the CPU, you're eventually going to give out. So if you'll notice, the system actually has even a reduced countdown timer. It's only at 6 seconds because it's going to know that the crash is going to occur, and it's going to reboot. And essentially, it's going to log all this information from the last recorded results and knows, okay, I need to now make an adjustment. I know what I've reached as my maximum capability. But this is the same thing we manually do, right? When we overclock, right? We keep overclocking until we crash.
Until it crashes, and then you
go back,
take a step back.
And then you make your adjustments, and you complete it. So there's no difference here. So once again, going back to even the enthusiast users, the big thing is that even if you still want to do this manually, run it once when you first set up your system, and you at least got a baseline of what you know what your system is probably capable of, right?
That's what we tend to do.
You know, so this still gives you an idea. Look, I know what type of voltage my system might need. I know the thermal characteristics. I know what type of margin might keep it capable. So you get more information. So it actually, if you notice, now finished the TPU section. So that means we've completed all your auto overclocking for you. At this point,
it knows what clock speeds it's going to run at, what voltages it's going to run
correct.
at, and memory speeds and all that kind of stuff.
So the EPU, we went in, and then we also made some optimizations to allow for maximum power efficiency. And what it also even does for the EPU that's pretty cool is we have for this generation the ability to shut off power to supplemental controllers on the motherboard. So such as like your AS Media 1061 SATA 6G controller or your additional USB 3 controllers on there. If nothing is actively being written to or read from those ports when they're in Windows, we can turn off the power to those devices. So it only saves you a couple watts, but hey, it's a couple of watts every single day, right? And that's all towards helping to give give you overall better power efficiency. So now we're going through the actual fan tuning process, and the cool thing about here is that if we start to see the fans, you're going to start to see them like rotating at different speeds.
Can we shrink that lower third just, or that?
And you can see that the last fan actually even stopped spinning. The top fan now just stopped spinning, because it's what it's doing is it's fully going through and measuring the full profile of operating metrics for the fans. So we go and see what's the maximum power that's required to drive it to the maximum RPM rate, and what's the minimum level.
Okay.
And what this allows us to do is essentially store this information per each one of the headers, so that when you go in there and you click on any one of the fan profiles, it knows what those values are. So when we click on full speed, it knows the effective full speed of what your fan is, or you could click standard and you could have a really nice balanced fan profile, or when you click on something like silent, if you're just watching the latest PC per podcast or the latest video,
right.
The cool thing about it is what? It's going to be
silent.
PC
per podcast.
Right. You can just click silent and all those fans will turn off, because I'm just watching a video. Why do I need all my fans to be spinning, right? There's no reason, so I can get that optimal balance. So we're tuning through every single one. We're tuning through all these little different fans. We're logging all this data for you real time. It's all set up for you real time here. So it's logging this information for each one of the headers. And the cool thing is, like I said, afterwards, you can go in and you can even, like I said, rename each one of these headers. So if I want to take the chassis fan headers that I have for the front two and relabel them to, let's say, front intake fans, I could label that, then label my top ones as inward intake, and then my last one is exhaust. Even my CPU fan, if I want to call that Noctua, NH cooling fan, I could call it that. So it's very flexible. You can see here on the screen we've got the different profiles that we're talking about: standard, silent, performance, and full speed. So those are all very easy to kind of understand, I think, as a user. It allows you to just go, depending on what I want, I can make those adjustments, and this will all be logged in for you. Now, one last thing too that's also pretty cool for this generation that we didn't touch on for the TPU and the auto optimization technologies, we have incorporated to register SPD and XMP profile data. So this will also reference the fact that at default this memory only runs at 1333.
Okay.
A lot of users don't know that they have to enable XMP to get the full memory rated specification. So we will also reference the XMP table, and if we think that it's okay, we'll also auto enable that so that we get that improvement not only on the CPU frequency side, but we also get that on the DRAM frequency side. Now, this is a performance oriented system, so in most situations people are going to run a discrete GPU, but if you did happen to run the iGPU, it will also dynamically overclock the iGPU for you as well. So if you wanted a little bit better performance from your iGPU, maybe you're really on a budget and you're gaming on Haswell.
Yeah.
Maybe you're more into, online based games, like Battlefield Heroes, or things like that, or even, some of the older source-based engines or early Unreal 3 based engines. You could get away with that on the Haswell graphics architecture and have a fairly decent performance. And if you're using some moderately high-speed memory as well, that when you overclock the iGPU, you can actually get sometimes upwards of about 20% increase on the performance. So it can be a healthy little bump depending on how you've got your system tweaked and tuned.
Cool.
So we finished that up. The VRM section went so fast that we didn't even get to touch on it, but pretty much all that did was it took those Digi Plus power settings that normally are things that like people don't fully understand, like phases or like OCP options or things like that, and it tweaks those to be in line with what our system's been tuned for. So at the end of this, we've got now a full four-way optimized system, and we can see here from the CPU side, we have an effective 4.9 gigahertz overclock, so that's done on 1 and 2 cores. 4.8 is done on 3 and 4 cores.
Wow.
We have an adjustment to our EPU from an away state. We can go ahead and make a small reduction to the power that's being utilized in the away state to 66 watts. We've customized every single one of the fans. They've all been categorized and logged, and we can see all the information per each one of these headers as far as what's their correlating fan speeds, what they operate at. We can see all that information. And lastly, we of course have the Digi Plus power settings. And now if we go back to our primary screen, you can see here that we have some data, some value points that have been plotted in, right? It shows us our new performance increase, the fan benchmark data, which can go back being referenced, and we have these other adjustments. So let's go ahead and while we have our own utility, let's just open up a third-party utility for reference here.
Okay. So
we're going to go ahead and use Ada as our reference. And we can go ahead and go here. And we can see that the memory has gone ahead and been set to 2133. And you can see right there, we're idling, right? But what's happened? The CPU frequencies come down and the core voltage is down, right? So we're getting that great benefit of being efficient, right? We're not using that static voltage or that manual vid, which is really inefficient. And if, let's say, we open up something like here, like Cinebench, and in most situations, this is going to be a significantly higher load than what a normal user does. Even if you were to run a game engine, game engines tend to vary between about 25 to about 50% CPU core loadings. So this is going to be an example of, let's say, we went ahead and just ran all cores. We could see an example of this. So we can see right here now it's running a full multi-threaded workload, and we've ratcheted up to, of course, 4.8 gigahertz, and we have our effective voltage under adaptive has gone ahead now and increased the voltage. And we can see that things are running well. So I think this is an awesome, easy way for you to really get a high level of performance in your system. I mean, you could argue that maybe I could get, I don't know, maybe I could stabilize 4.9 on this, but is it really worth it? You know, in my opinion, I'm not. I mean, you know, 3.5 to 4.8, even if we don't count the per core tuning, it's a pretty nice increase in performance for clicking a single button. So it's pretty awesome implementation. You know, like I said, it can take you a long way there. In some rare instances, like I said, if maybe, like I said, 9 out of 10 cases, you find that there might be a slight instability. The thing is, you'll still be very close to the effective margin of what the voltage will be, so you can manually add just a small amount to help to stabilize, so it still gets you, you know, 90% the way there. Now, if we look here when it's going to run the single thread, because of course what are called the MSRs, or the loading tables, are so fast, you might not always see it register 4.9, but at some point throughout the benchmark, it'll ratchet up on those 1 and 2 cores to about 49x, because that's where the single thread loading is at.
There, I just saw it hit there. It's
it'll go to 49. So you can see we've got that really cool per core tuning in effect. Now, the last thing that we do want to touch on here is something that we talked about at the workshop, which is with this new adaptive voltage, there is a large consideration point. Now, we are not generally fans of synthetic-based stress test applications such as Prime 95, Intel Burn Test, Lynx, things like that. Not so much because there's anything inherently wrong with the programs, but because they don't go through an extensive layer of validation from us or even Intel. As such, we always caution people using these stress test applications. For this generation, though, you have to even be more conscientious of this. With the adaptive voltage, if you run one of these type of synthetic workloads with an adaptive voltage, the PCU, or the portion of the processor that can request voltage, which we have no control over, can increase the amount of voltage that's actually supplied regardless of what's been defined by you or even by our program. So if we talk about that 1.25 volts, right? If we were to run, let's say, like Prime on this, which keep in mind right now, Prime is not even validated for Haswell. It'll take them probably like a month or two to update the build to even recognize the CPU correctly. It could go an increase of like over 1.35 volts. So 1.35 volts could probably only be handled by like a triple cooler radiator, real water cooling situation. So keep in mind, you would pretty much almost go into instant throttle, and there's no way that you can control that. That's automatically going to occur during the process of you running that. So this is why we recommend real world applications, you know, whether it's things like, you know, PC mark, pass mark performance test, pass mark burn-in tests, things that not only have current instruction set support, but also use the memory, the subsystems like storage and the GPU always do a great job of really effectively giving you a sense of what your system is doing. So that's a little bit of a preview on 4-way optimization. And the cool thing is that, like I said, that's pretty much on all the mainstream series motherboards. So you get that really awesome technology on a board all the way down like our Z87 Plus, or on something like the Pro, or even the Deluxe, or even the little mini ITX-i board. And it'll be variable to your system, which is really the great thing.
It's pretty cool.
Yeah.
It's pretty good.
So that, I think, shows off what we wanted to show there with 4 optimization. I think next off we wanted to show the UEFI, right?
I think we want to show the alternative here, which is if you want to use that as a starting point, or if you want to do it manually, if you're one of the people that you definitely want to get into the EFI, UEFI, and I still can't say that word correctly, and tweak things. Let's go in there and reboot into that and see some of the options that you guys have added for the Z87 line. I think that would be compelling to see.
So the big thing, I think, for this part that we're going to talk about with the UEFI is, you know, we were really kind of foreleaders in that we rolled out UEFI in every single one of our chipsets before anybody else, and that's something that we really pride ourselves on. At the end of the day, the UEFI is an advanced user environment. It's really designed for people that feel comfortable manually tweaking and tuning their systems. But the thing about it is that when you go in there, you know, you want to maintain, I feel, the best level of kind of fluidity, response, and intuitiveness. And for us, when we decide to make changes to the system, we take those very seriously because we don't want to compromise on things like the layout, the response, and the fluidity. So for this generation, what we've decided to incorporate is really keeping the same comfortable layout that you've come to expect from ASUS and their UEFI, but adding features and functions that we feel really add value to you as the you as the user. Okay, so you can see right here we've gotten into our UEFI. We've got the easy mode interface like we've had actually for a couple of generations now. The big focus for us for this generation was to try to incorporate more real-world usability elements that are kind of the things that you immediately want to take action on, but require maybe more steps than really makes sense to do. So the first one is right here in terms of DRAM information. One, we've updated to have a visual mapping of all the channels of memory so that you can immediately know who's the manufacturer, what's the density, and what's the frequency of that memory. So this is a great way to just know, hey, all my memory modules are coming up correctly. I've got no issues there. But the next level is going to be XMP. Most of the memory kits that are purchased on the market tend to be XMP enabled right now. And a lot of users don't know that you have to go into the next layers to be actually enable this. And you normally have to go to advanced, AI tweaker, manual, and then XMP, right? It's a lot of steps, whereas now for this generation, we just have a single click option. You can just go ahead and click on that profile and go ahead and load it, and it will automatically load the XMP for you dynamically. So this is a really nice plus in terms of giving you that benefit right off the bat. The next step is going to be right here with the fan controls. Same thing. Why do you need to go all the way into the heart of the UEFI under the hardware monitoring section and the tools to be able to make adjustments? Sure. We can now just go ahead and expand upon these and look at each one of the headers, and if we want to make an adjustment to the fan profile, we can click on silent and we can apply that, and now that profile will be dynamically set to that header. And that's great, as you can see that when we talked about our motherboards having per header control, you can go in there. Now there are still more advanced levels of fan control available, such as manual, where we can individually target like maximum RPM, minimum RPM with target temperatures, but that's a bit more complicated to fully lay out, so you still have to go into the advanced section for that. But for the basic profile options, those are immediately available to you. Okay. Then we have, of course, quick profile, quick performance parameters. So you can do like a quick overclock of about like 4.2 gigahertz plus here, stock operation, or here power saving, which does not affect performance. It just applies an undervolt algorithm to the CPU, so it gives it a little bit less voltage. So that's just going to help to give you a little bit less in terms of total power consumption, maybe reduce a little bit in terms of the peak temperatures. Below that, we have easy drag and drop boot priority, where you can assign the device that you want to go ahead and boot and initialize into. And then the last one is going to be a new item here, which in the same vein as that easy recognition for what you have installed DRAM rise, you have SATA information, which allow you to immediately see all the devices connected to each one of the SATA ports. So it's another quick, easy way to confirm, hey, these are my storage devices. So that gives you a little bit of perspective. A lot of changes there initially in the easy mode, even though it might look like the same type of interface as what we've previously had. Now, if we jump into the advanced section, this is where we've had a whole nother layer of functionality that we've introduced. The first one is going to be here and this My Favorites tab. So if you remember in previous generations, we had what was called an F3 shortcut option. The F3 shortcut option was a great way to have like a table of contents that you could just jump to, easy parts of the UEFI. But our goal was to always have this to be more customizable so that you could manipulate and manage the UEFI in the way that you want to. Most people at the end of the day use between maybe like 5 to 12 settings in the UEFI. You don't use all these options and switches. It really depends on your usage model. So why can't you set it up in a way that's more specific to you? And for this generation, you have. So an example might be, let's say I go to AI overclock tuner, right? And that's something that I would change. I can now go ahead and highlight F4, and I can set that to my favorites page. I want to also maybe go ahead and set my core ratio to be something that I want to go ahead and define. So if, let's say, we went here and we synced all cores, I want to go ahead and add that to my favorites. Maybe I want to also go ahead and add my DRAM divider, so I want to make some adjustments there. And I want to go ahead and also apply my voltage table, so I can go ahead and map that there. And maybe I want to do the manual. Maybe I want to define that as well. And you can go in there and you can pretty much map any of those. Maybe I also want to go ahead and map in which options are most consistent for me if I want to do that. And even from a monitoring standpoint, maybe I want to make customizations to my fan controls, right? So I can go ahead and select that option. So the great part about that is now if I go back to my favorites, I can see that I have now all these portions immediately available to me.
That's pretty cool.
So if now I want to even define the basic elements of overclocking, guess what? I can do 46 here. I can define my 1.2 voltage. I have a rate enabled on my system, and I want to have this set to an advanced mode for my fan calibration process. And anytime I keep coming back here, I can make those adjustments just from that section, and I can make that as robust as I want, or I can make that as lean as I want, or if I just want to keep the UEFI the old way, hey, do it the old way. It's really up to you, but we feel this adds a whole nother layer of ease of use at working with your system.
Yeah,
and you can also add it to the shortcut field. So it's really up to you. Do you want that my favorite structure, or do you want maybe additional shortcuts that you can just press the F3 and it will immediately jump to you that section?
Jumps to that.
So if I click now on monitor, it jumps straight to the monitor section.
Okay. So it doesn't move it to a separate page, it takes you to that page.
Correct, it takes you to that page. So two different ways in terms of working with the system, but really nice points of flexibility.
Cool.
So let's go ahead and go back to, excuse me, let's go here to the main tab. So the next one is going to be one that we worked really, really hard on, but I think is really cool, and that's going to be the quick note technology. So here you can see, oh, PC previewers are awesome. They rock.
This is a setup.
So it's something you guys saw. I actually input this previously in there, but I also made a quick little note. You know, 4.6 gigahertz needs approximately 1.2 vids to ensure post and boot stability, right? And the great thing about that is, I don't know if you're like me, Ryan, when I'm tuning my system, I usually have like a tablet or a piece of pen and paper there.
Yep.
Sometimes I'm taking notes, right?
Usually on paper.
But the great thing though is that, you know, sometimes you lose that paper, you misplace it, you know, you spill something on it, you get enchilada sauce on it, you know, who knows what happens, right? But, you know, for this generation, we can keep things logged in there. So what you could then next go ahead and do is that, you know, 21, 33, you know, memory was not stable with, excuse me, if I can type correctly, stable without, you know, adjustment to the I/O voltage, right? And you know, the great thing is you could save all this information, and it doesn't matter if I come back to this a month later, right? Maybe, you know, my system settings get reset, maybe something like that. I can go back and I can reference the quick note information that I have in there, and I could know exactly how I tweaked and how I tuned my system. You can log all that in there. So we think this is a whole nother layer of being able to really add an easy use element and keeping a track to a lot of the adjustments that we make specific to our system, but without having to remember, hey, where did I put that information, or I don't remember everything that was going on there. So that's a really nice option that we have integrated. Another one is going to be this last modified option, which you can see I made quite a number of changes to the system in terms of my last reset. And that records all that history for me real time. So sometimes when you're making all these adjustments to your system, you might not remember every single thing that you've changed on, but maybe it changed reaction to your platform. So now you can track this information when you repost it. If you need to check that, you can check this last modified history tab. And we'll see that actually when we make some changes at the end of this, if you go to when you save your exit, it'll actually let us know every item that we've made an adjustment to. So an example is if I go back to, let's say, AI Tweaker and make some quick changes, such as, let's say I want to go ahead and default this back over, and I'm going to make an enhancement to here, and I want to go in and sync all my cores, and I'm going to do 46, and I'm going to make an adjustment to my voltage as well of 1.2. And we'll make some other items. We'll see how we actually can also record this for you so that you can visually confirm this at the end. So the next up here is in our advanced section, which is here you normally see all these options. But one of the cool ones that we added here for SATA configuration is going to be in these ports. Now you can see right here, of course, we show you all the hard drives, so it doesn't really look like there's anything different. But the cool part is now I can select this field, and guess what? If you're a storage guy like me, you're going to love this option. So what I can do is I can go ahead and go in here, and I can delete this, and I could call this my primary Windows 8 SSD. And now I've named the actual port itself. So this is great. Like one of my systems at home, I have 3 2-terabyte Western Digital black drives, right? But they're all the same. And sometimes you're going in there and you don't remember which drive is for which purpose. So it could be like your Steam library, one's your personal backup, and the other one is maybe like your media center drive, which you do backup on or whatever, right? But here now, if you ever make any of these adjustments, as you actually add more complexity to your internal storage configuration, you can name each one of these, and that way you have an immediate recognition of what this environment is, but without having to be in the OS environment. You can essentially just name it to whatever you need to. So that's another really nice option that we've incorporated here for this generation. The next one is, of course, going to be in the fan control options. You can see that the same level of extensive control that we offer in the OS is fully available to you there. per each one of these headers. So if you can see, if I just selected 2 of these headers as an example, we have those both set to manual target modes. And that gives us a whole lot of granularity that these are going to go ahead and change based on upper temperatures or minimum temperatures and corresponding duty cycles. So with that, pretty much rounds out some of the new options that we have here within the UEFI. There's even more new options that we have under the ROG series of boards, which we'll touch on very lightly when we do the overclocking section on that board.
Okay.
But you know, I think the big thing is here is it's not inherently doesn't look too different, but when you talk about the actual real-world usability, there's quite a bit more functions that we've incorporated for this generation that we think makes the UEFI even easier and more useful to work with as an enthusiast. So if we lastly went ahead and we saved our options, so if let's say I go ahead and say F10, you can see right here it immediately shows me all the items that I've decided to make an adjustment to, such as my core ratio, my memory divider, my voltages, even my DRAM timings. So this is a nice way that, hey, right before I've decided to commit to all these settings, I have a way of knowing, this is everything that I changed on. And sometimes you make a switch to something, or you didn't make a switch to something, and you wanted to change it. So this just gives you that additional layer of comfort to know, hey, this is what I made the change on, and you can go ahead and reboot.
That's pretty cool.
So that wraps up the new additions that not only we've incorporated to AISuite III for optimization, but also to the UEFI.
All right, we do have another demo. We're going to show you some overclocking on the Maximus 6 Extreme, right?
As well as, yeah, some tips and tricks on, you know, how you can hopefully take advantage of, you know, your ASUS Z87 board and your Haswell K-series CPUs.
Before we do that, we're going to have another contest, another giveaway, another live chat response giveaway. Do you have a question?
Okay.
Will you write that answer down for me again? Again, this is all reaction time and research time. It needs to be validated on this. I think for this one, we'll go ahead and give away the DC Mini.
Okay, the DC Mini.
GTX 670 graphics card. That is a... Is that the card that's in this system?
That's the card that's in the system, yeah. It's got that brand new fan design where it's got the...
Here, if we show it here, there you go. There it is.
Yeah, it's right there. It's got a cool little vapor chamber design. It actually is both a blower and an actual kind of axial-based design, so it brings in air, but it also pushes down at the same time. It's pretty awesome. It's a 670, full stock 670 performance. Great downclocking.
So JJ's going to write down the secret answer so he can't cheat when we start scrolling there. So we're going to give away a 670. And we still have, after this, at the next segment, we'll give away a Z87 Deluxe Dual motherboard as well. That's the dual Thunderbolt option. So, very good.
Let me think here.
Trying to make it less or more difficult than the last question.
I could make it more difficult, but
don't make it more.
I think I'm gonna.
Don't make it more. Make it less.
Make it less?
Yeah.
Okay.
Yes, RGB. It still does take screenshots in the EFI.
That's right. 100%. F12 all night long, man. All night long. Okay. I think I got one.
All right. Write down the answer for me.
Okay.
They're worried about you thinking too hard. It's bad news for them. So. And writing on the table is difficult with all the holes in it. I heard some people commenting, or saw some people commenting on that earlier in the chat room as well. All right.
Okay. Oh, wait. Hold on. Sorry.
Actually put down the answer, too.
Yes. I realized that.
That's a good one. All right.
I think that's not too hard, right?
No.
Yeah.
You have to put this all in one line of text. I'm not going to be able to follow if you answer the 3 parts.
Yeah, I recap on that. I think Ryan's 100% right. Just make sure that the answer is one complete sentence. Right. Yeah, don't break it apart. So you guys know that we make awesome graphics cards. We really pride ourselves on our non-reference designs. And PC Perspective has had the chance of seeing a lot of these very specialized hardware designs that we've brought to the market. So we have 3 branded names for ROG graphics cards that are kind of our very, very special designs. Some of these are like limited to like 1,000 pieces, and some of these have featured such specialized technologies like a dynamic LED load balancer, which shows you the actual loading policy for the GPU.
Right.
So what are the 3 names for these series of graphics cards? Let's see who can figure this out here.
It's already done.
Wow, somebody was that good.
It was done before you finished the question.
Cedo Skull.
Cedo Skull. I like that name, man. Cedo gets some kudos.
The answer is Ares, Mars, and Matrix.
Dude, money.
RGB had the first answer out, but he had Ares, Mars, and Poseidon.
Oh.
Sorry. Man, that one was apparently too easy.
That was. See, I told you, man. We got some smart people here. I should have made it more difficult.
So, Cedo Skull, I sent you a message. We can get your email address. We still have another motherboard to give away in our live stream. We're going to go ahead and do a quick system swap, shut this down, bring in a new rig, and we're going to show you overclocking on the ROG system. And we will also talk about RAM disk and maybe get into a couple of other little things too before we sign off. So we will be right back.
Stay locked.